Alright, we're here in section 2, adding and subtracting fractions, and going to give you a couple steps and basically do a bunch of examples. So here, first thing, we'll just say the steps. To add or subtract fractions. And we're not doing mixed numbers, so not like 1 and 2/3, we're just looking at like 2/3 plus 7/8 or something like that. So first thing, rewrite fractions with common denominators. So rewrite fractions with common denominators. In normal person language, that would say the bottom of both fractions need to be the same number. And then add or subtract the numerators, depending on what it's asking you to do. So add / subtract the numerators. And leave the denominators the same. That's the rookie mistake, is people combine the denominators, but leave the denominators, the number at the bottom of the fraction, leave the denominators the same. And then last but not least, reduce the fraction if possible. Comma, if possible, at the end. Alright, I have 4 examples planned, and those examples in theory will help it all make sense. Let's give it a shot. First one I want to do is 1/3 plus 5/9. So my first example or two is going to have it be where we just need to change one fraction to get the common denominator. And for this here, we either need to change the 9 into a 3 or the 3 into a 9. To avoid making a decimal out of that 5, easiest is going to be to say, well, what do we multiply 3 by to get 9? And it'd be 3 times 3 gives me 9. Well, if I'm going to multiply the denominator by 3, I need to multiply the numerator by 3 also. And here's why. If you look at that 3 over 3, and I wouldn't write this, but 3 over 3 is really just 1. So essentially what I'm doing here is I'm taking 1/3 and I'm multiplying it by a 1. Well, any number times 1 just is that number. 1 is the identity element of multiplication, they call it. So I'm taking this first fraction, multiplying it by 1. It changes the look of the fraction, but it really doesn't change its value any. So 1 times 3 is a 3. 3 times 3 is a 9. So my first fraction, 1/3, is mathematically the exact same as 3 over 9. And now I can add to that my second fraction, which was 5/9. So I have my 3 plus 5, which is 8, divided by, keep the denominators the same. Kind of the rookie mistake is people change this to an 18, or I've seen all kinds of crazy things happen. But the answer is going to be 8 over 9. I should pause and say, well, can we reduce that? So are they both even, in which case you could divide by 2? Nope. Could you divide them by 3? 9 you could, but not 8. Divide by 4, 8, but not 9. So anyways, you kind of go through the numbers. That's reduced. My second example is going to be similar, but I'm going to say it's 1/2 minus 1/6. So it's subtraction this time, but we're going to do the same series of steps. We don't have common denominators yet. Easiest to change the small one to a larger one. So what do I multiply 2 by to get my 6? And I multiply it by 3 again. And if I multiply the denominator by 6, I need to multiply the numerator by 6. So my 1/2 becomes 1 times 3 is a 3, 2 times 3 is a 6, and 3/6 is the same as 1/2. And now I subtract 1/6. I don't need to change that fraction because it already has a denominator of a 6. Where before I did 3 plus 5, now I do 3 minus the 1, and I end up with a 2 over a 6, and keep the 6's the same. Now once you're at this step here, hopefully you recognize that you can reduce that. They're both even. So in order to reduce it, divide both by 2, or you could say 2 is the greatest common factor of those. 2 is the largest number that goes into both. And my 2 divided by 2 gives me a 1. 6 divided by 2 gives me a 3. So final answer would be 1/3. Kind of why is that legal? This dividing both by 2 is really kind of the same as when we multiplied by 3 over here. That when you multiply or divide by the same number, essentially I'm dividing 2/6 by 1, which doesn't change its value at all. Alright, cranking right along up to our third example. Third example will be a little tougher in that it's a little harder to get common denominators here. So I have 1/5 plus 1/4. So 4 is my smaller denominator. I can't nicely change it into a 5. I'll see some people that try to, well, if I multiply by 1 1/4, but then you start getting like decimals in your numerator and it just gets ugly from there. So what you really should do is look at, well, what number do they both have in common? Something that you always can do, it might not be the least common denominator, but I could take and multiply the 5 by the 4. So I'd multiply them both by 4 over 4. And I could multiply the 4 by a 5. And that's something I've often done. In this case, that is going to be the least common denominator. If you're not sure, you could go through and list out multiples of them. So I'd have 5, 10, 15, 20, 25, 30. So these are my multiples of 5. So those are the options for common denominators there. With my 4, I have 4, then I have 8, then I have 12, then I have 16 to get close. But then right there, 20 is going to be the first number that I could change the 5 into a 20 and the 4 into a 20. So you could say, well, 5 times what gives me 20 happens to be 4. 4 times what gives me 20 happens to be 5. So it doesn't always work out that that gives the least common denominators. But now if I have a 1 times a 4, it gives me a 4. Over 5 times 4 is a 20. So 4 over 20 is the same as 1/5. 1 times 5 gives me 5. 4 times 5 is 20. So I have my common denominators. Now I add the numerators because it's addition. Keep the denominator the same. So 9 over 20. And you just have to say, well, with that 9 over 20, can I reduce it? They're not both even. You can't divide them both by 3. This by 4, not that one. So as you go through the different numbers, you'll find that that is the most simplified one. Alright, one example to go. I'll just scroll down here. And the last example, it's really the same adding fractions, but they combine it with something that we did earlier this year in my classes. We're going to say solve for x. So we're going back to solving an equation, but now we have fractions in it instead of nicer numbers. So I'm going to say x minus 1/4 equals 1/3. So if I want to go through and solve that one there, well, what do? Look at what was done to x. We want to do the inverse. We had x and 1/4 was subtracted from it. So to undo subtracting a 4th, we add a 4th, which then gives me x equals 1/3 plus 1/4, which now gives us a problem like what we've been doing the last 3 times. So if you're looking for common denominators, you could do 3 times 4 and 4 times 3. That's actually going to be the least common denominator because you have 3, 6, 9, 12, 4, 8, 12. So 12 is the first number they have in common. Multiply my first fraction by 4 over 4, my second fraction by 3 over 3. And that's going to give me 1 times 4 is a 4, 3 times 4 is 12, plus 1 times 3 is a 3, and my 4 times 3 gives me a 12. Then I add my numerators together for a total of 7, keep my denominators the same as a 12. Then we look at, could we reduce that? Again, we have an even and an odd. Only 12 is divisible by 3, only 12 is divisible by 4, and so on until we find out that we're there. I suppose a faster way would have just been to say 7 is a prime number. You stop with a 7. So that's it for adding, subtracting fractions. Give it a shot. Let me know if you're stuck. Be glad to help you.